Hello, grade 12. Welcome back to our Physics 2 class. So let us now proceed to another topic. Okay, this is not related to electricity no more. Okay, so we will now start another one. So the title of this topic is about this. So I will share my screen. Okay, so we have differentiating electricity and magnetism. Okay, so we are done with electricity. Let us now continue our physics 2 class with magnetism. Now, let us differentiate those two. So that will be our topic for today. Okay, so a compass is very um, just like this is not really a new to us, right? So we already know what compass is. Compass is used to find the right direction. Okay, it's because this one is actually related to the magnetic fields of our planet or the Earth. Okay, compasses are actually magnets suspended freely inside the grass where it is being attracted by the magnetic poles of the Earth. Okay, so this one is related to the magnetic fields and poles of our Earth or of our planet. Okay, so this one is the best application of what magnetism is. Okay, so let us dig more, okay, about this magnetism. So in this lesson, you will know about the nature of magnets, such as a compass and how it differs from the properties of electricity. Okay, so why do we need to do this one? It's because sometimes the others are thinking, okay, that if electricity also has attracted something like that, something attracted two parts, and also magnetism magnets also has two parts that are attracted. So they are thinking about they are the same, but not. Okay, so we will learn here the difference between those two. Okay. Yeah, so how do electric and magnetic interactions differ? So this will be our main goal, okay, or main question we will answer after this class. Okay, let's start first with our vocabularies. Okay, first one is magnetism. Magnetism refers to the force applied by magnets to each other whenever their magnetic poles attract or repel. So we have here the word whenever. Ibig sabihin, kahit anong process. Right? That's whenever. So here, when we say magnetism, it refers to the force applied by magnets to each other whenever their magnetic poles attract or repel. Okay, so if we are using magnets, okay, and then we play those magnets, if they attract or repel, that is still a magnetism. That is called magnetism. Okay, it is the result of the interactions between moving electrons in objects. Interactions between moving electrons. Okay, so they have the sameness with the electricity. It also has some electrons. Okay, and as I have told you last time, electrons are okay. It's all around us, right? So we cannot see them, but we the science still said that electrons are everywhere. Okay, it is a result of the interactions between moving electrons in objects. Remember, magnetism is the force applied or interaction. Okay? Pag ginalaw mo yung magnets, it's either attract or repel, it's still magnetism. Okay? So this is just a story about magnetism. Okay, the Danish physicist Hans Christian Ørsted, I don't know how to spell that name, first established that moving charges cause magnetism by accidentally, but almost all the inventions and almost all the just like learnings that we had now, okay, are based on accidentally. Okay, so parang yung accident na yun, it brings us another learning, right? So that is one. Also, di ba, sa math natin, just like the Cartesian plane is also accidentally learned by one mathematician, just like sleeping and then see something on his ceiling, okay, and then naisip na yung Cartesian plane. So just like this one, so it's accidentally invented, okay, demonstrating how a wire that contains electric current could deflect a compass needle. So this is still a relation between those two, okay? So kung mag-Venn diagram tayo, this is magnetism and electricity, excuse me, we can write something about their sameness later, right? So that is one. When the wire carries no current, okay tayo. When the wire carries no current, may walang kuryente, the compass needle points north. Okay? So north siya. When the wire carries a current, the compass needle deflects or gumagalog-galaw na ganyan. Okay? The direction of deflection depends on the direction of the current. Okay? You will learn later yung sa experiment na nandito sa ating PowerPoint. It will explain also this one. They are the same. Okay, but that one is more easy to understand. Okay, so the main purpose of this one is just we just know that Hans Christian Ørsted is the first person to discovered magnetism. Okay, or moving charges caused by magnetism. Okay, attraction happens when two opposite magnetic poles are placed alongside each other. That's basic, right? So they will attract if north and south yung ating pagdidikitin. Okay? They will attract each other because they are alike. So attract unlike magnetic poles. Okay, easy. North and south, south and north. They will attract. Diba? Parang pang grade 5 lang. On the contrary, of course, we have the word repulsion or repel. You know, pinaka-basic diba repel? Occurs when two similar magnetic poles, north and north, south and south, are beside each other. Okay? So if we will, just like, pag didikit natin yung north and north, we cannot. It's because they are the same. So magre-repel lang sila. We cannot force them to, you know, to join their sides together. Cannot. Okay? They will repel. So unlike poles attract, like poles repel. That's the main summary for that one. So it's not that hard to memorize. It's because we already know this one when you're elementary days. Okay. If a permanent magnet can spin or rotate freely, the side that points north is considered its north pole. Okay. And the side that points south is its south pole. Like poles attract and unlike ones repel. So there are also some magnets that are, kung alam mo yung, ano siyang all around, parang ganun. Okay? So if that magnet, uh, points sa north, that is its North Pole. And of course, the other side is its South Pole. Okay? So this one is the expectation. Why? Okay? There is also a magnetic force around us. Okay? Magnetic nature of the Earth. So there is a magnetic nature of the Earth. When you say nature, nature is already constant there. Kumbaga, hindi mo na siya matatakasan. Kumbaga, ganyan. Hindi mo na siya how do you call that one? Parang hindi mo na siya matatanggal. Because it's already nature. Okay? So, magnetic nature of the Earth, we have magnetic north and south poles should not to be confused with the geographic north and south poles of the Earth. Why? Because unlike poles attract, the Earth's north magnetic pole is its magnetic field's south pole. So, parang magulo, di ba? Sabi dito, yung north ng ating planet is the south pole of the magnet. So paano yun? So we have here an illustration. Okay? This is an illustration of the magnetic fields that are passing all around the world. Okay? So we have here this part. This is the north. North only, ah? Hindi siya North Pole. North. And this one, pinasa baba siya. This is the south. Okay? North geographic pole and south geographic pole. So it's this one is different from the south pole and the north pole of a magnet. Okay, so we will explain that one. It says here the geomagnetic north pole is actually magnetic magnetic south pole. Okay? So yung explanation kanina, yung north part ng ating planet actually has a what we call the south pole ng magnet. Okay? South pole ng magnet. And then of course, the other hand, since they are opposite to each other, so this is now North Pole. Okay? So hindi parehas yung magnetic poles ng ating planet sa magnet. Okay? So yung north side natin or north pole natin sa Earth is actually the south pole of the magnet. Yung south pole ng ating Earth or planet is actually the north pole of the magnet. Okay? So these are the direction of the compass. As you can see, we have here some arrows. That means this North Pole, okay, was attracted by the South Pole, correct? So they are just rotating. Umiikot lang siyang ganyan. Ikot-ikot lang. Okay, yun yung, that is the magnetic nature of the Earth. Okay, so hindi naman siya magkaiba. Okay, it's just the directions or the positions, okay, of north and south pole in the magnet itself and in our magnetic nature of the earth are opposite. Okay? So yung north pole ng earth, it must be the south pole of the magnet. South pole naman ng earth, it must be the north pole of the magnet. Okay? That's so easy to understand. The blue lines are called magnetic field lines. Okay? Magnetic field lines or relate this one into our electric field lines. Kung sa electric field natin, we can call that one as electric flux. Here also, we also have magnetic flux. That's also a field line. So it's the same. And they signify the compass direction for each location. Okay? So kung nasaan yung North Pole ng magnet ng ating planet, okay, doon naka-direction or naka-direct yung ating compass. Of course, it is susundan niyo is always the north. Okay? Magnetic fields are caused by the electric current generated from the core of the Earth and change their direction irregularly after thousands or millions of years. So, hindi siya everyday. Okay? So, kumbaga, if now our north is here, it will last until it will reach 1,000 years or million years. It depends. It's irregular. So it depends. Okay? But the thing is, it must be after thousands or millions of years. Okay? Another thing with the difference between those two, okay, magnetic poles versus electric charges. Electric charges can be isolated. What are the two Okay, what are the two electric charges we have? We have the positive and negative, right? They, if they are also on like side, they can attract, right? But the thing is, if we will cut them, this part is only positive, this part is only negative, okay? So they can be isolated as two, okay? It can be either positive or negative, correct? But magnetic poles always, okay, I bolded the word always, come in pairs as shown here. So if you imagine if we will break a magnet into two, we cannot say that this one is the North Pole and this one is the South Pole. No. Okay? Whatever the thing is, if we will cut this one, is still, if this one is the North, the other side is always the South. This is the north, the other side is always south. So, two, yeah, whenever the two magnets or the magnet breaks, okay, we cannot isolate the two poles. They are still in the magnet. Kahit magpira-piraso man yan, may north and south pole yan. Okay? That's the difference between those two. In electric charges, if we will separate positive and negative, this one is positive, this one is negative. So we can isolate them. But in magnetism or magnetic poles, they cannot be separated. Okay? Sabi ko kasi kung durugin mo yan, yung pinakamalit na magnet na yan still has north and south pole. Okay? Okay. So this is the experiment, okay, did by Faraday. And this one is the same as the experiment or the accidentally tawag ito kanina, yung parang accidentally nagawa ng isang pang physicist. Okay? So this one is related. So this experiment proved that a changing magnetic field is required to cause a flow of current. So ano yung changing magnetic field na yan? Let's start with the middle. This is our middle. Since we're talking about changing, it means gumagalaw. Right? It's changing, so gumagalaw siya. So, if there is no movement, there is also no current. Do you understand? If you will just put your magnet here on this kind of metal and then some wires, there's no current. But if your magnet, if you want to move it in, okay, or papalapit doon sa wire and yung sa, what do you call that one? That thing, okay, na pinalibutan ng wire, if you do like that, yung papalapit pa lang, hindi mo siya dinidikit, but papalapit pa lang, we have a current or flow of current. Okay? Of course, kung papalapit ka, you also do the one. Okay? Palapit, do the one. Nakuha niyo yan? So, see, papalapit siya, then papaganon din yung ating arrow. And if we will move it out or moving out naman ang gagawin natin, susunod naman yung there's also a current of flow or flow of current na susunod yung direction natin sa ginagawa ng ating magnet. Okay? So kung may ginawa ka dun sa magnet and then just moving in, moving out, gagalaw yung ating uh, current reader. Okay? So, moving in, there's a flow of current. Moving out, there's also a flow of current, but in opposite way. Okay? Now, these are some important reminders, okay, about the differences between electricity and magnetism. Electric forces result from and interact with both stationary and moving charges. Magnetic forces result from and interact only with moving charges. Okay? So here, kapag sinabing electric forces, pwede siyang mag-interact both sa hindi gumagalaw at gumagalaw. Okay? Magnetic forces result from and interact only with moving objects. Yung magnetic is only in moving objects. Okay? Number two, this was number two. A single electric point charge exists. Dividing a magnet will always result in a north and south pole. Correct? Already discussed that one. Therefore, magnets are always dipole in nature. That's a constant rule. We cannot break that one is because it's already proven that kahit balik-balik mo, kahit balik-balik kahit durug-durugin mo yung magnet na yan, it always has a north pole and south pole. Okay? Number three, electric field lines, or also called flux lines, diba, have fixed starting and ending points. Tama? Kapag yung positive electron transferred or attracted by the negative electron, andun na lang siya. Okay? Why? Wala namang negative doon sa kabila. Diba? So na-attract siya, it's because wala siyang kaparehas. So it attracts. That is electric field lines. But in magnetic field, it behaves or it just we have the continuous loops. Lang sila, why that one is only rotating or continuous yung kanyang paggalaw or pag-ikot. It's because we have a constant north pole and a constant south pole. So, kung meron mga objects dyan, okay, they are just attracting each other all the way around. So, since north, south, north, south, south, north, north, south, south, north, north, south, south, north. Okay? So, the magnetic field lines behave in continuous loops. Okay, this is one of your activity. This is also a part of your activity. Part of your activity. Okay, let's solve everything. Magnetic forces occur when a magnetic field is produced around a moving charge or an electric current, which another charge or current interacts with. Okay, that is magnetic forces. When we say magnetism, this only refers to the force applied or the interaction between two magnets. Diba? So it's either they they attract or repel. Doesn't matter. It's still a magnetism. Attraction. Attraction, okay, if the magnet happens to be unlike poles, so they can attract. Repulsion occurs when two similar magnetic poles, okay, uh, combine or just like beside each other. Okay, so unlike attract, like repel. That's it. The motion of charges involve the presence of monopoles and the field lines are the three major aspects that delineate electricity from magnetism. So, para mas magaling siyang tandaan, this these three major aspects are the best thing to memorize or to understand so you can differentiate it into the electricity. Okay, the motion of charges. Okay, about the motion of charges, this one is continuous loops. Alright, presence of monopoles. And in break moving magnet, you still have two poles. And the field lines, okay, field lines is also continuous. So those are three are the main, uh, just like main thing to make it different from electricity. Okay, so if you have more questions about this one, don't hesitate to chat me okay on my messenger, and I will just send your activity in your keeper account. Okay, so see you again next time. Bye.